Next, property 4. If Gn belongs to G and Gn increases to G, then G belongs to script G. And pi of G equal to limit n tends to infinity pi of Gn. That is pi of limit Gn equal to limit pi of Gn. So G is closed under non-decreasing limits and pi is sequentially monotonely continuous. Suppose Gn belongs to G and Gn increases to G. We want to prove that G belongs to script G and also pi of limit Gn equal to limit pi of Gn. First we prove G belongs to script G. Since Gn belongs to script G, we have an approximating sequence. For each n, Gn has an approximating sequence. Bmn belongs to script A, such that limit m tends to infinity Bmn equal to Gn. Now we want to prove G belongs to script G. We know that script G is the class of full collections of countable unions of elements in script A. That is increasing limits of all elements in script A. For proving G belongs to script G, we want to prove capital G is the limit of a increasing sequence in script A. For that, we define dm equal to union n equal to 1 to m Bmn. That is finite union of Bmn. Since A is a field on closed under finite union, dm belongs to script A. Now we show that limit m tends to infinity dm is G. And also we show that dm is an increasing sequence. If it is true, then G has a monotone approximating sequence of sets in A. Hence G belongs to script G. To prove dm is an increasing sequence or to prove dm is monotone, dm equal to union n equal to 1 to m Bmn by definition. And Bmn, each Bmn is contained in Bm plus 1 n. It is contained in union n equal to 1 to m Bm plus 1 n. And this is contained in union n equal to 1 to m plus 1 Bm plus 1 n. And by definition this is equal to dm plus 1. Therefore we get dm is contained in dm plus 1. That is sequence dm is a non-decreasing sequence. Now we want to prove limit dm equal to G. If n less than or equal to m, by definition of dm, Bmn is contained in dm. And dm is equal to union j equal to 1 to m Bmj. Since Bmj, limit Bmj equal to Gj, it is contained in union j equal to 1 to m Gj. Call it as Gm. That is Bmn contained in dm, it is contained in Gm. Now letting m tends to infinity, we get limit m tends to infinity Bmn contained in limit m tends to infinity dm, which is contained in limit m tends to infinity Gm. Since limit m tends to infinity Bmn is Gn and limit m tends to infinity Gm is G, we get Gn contained in limit m tends to infinity dm contained in G. Now letting n tends to infinity, we get G equal to limit n tends to infinity Gn, which is contained in limit m tends to infinity dm, which is contained in G. That is limit m tends to infinity dm is equal to G. That is dm increases to G. G is the increasing limit of sequences in script A. And it proves G belongs to script G. So we get G belongs to G. Next we want to prove pi of G equal to limit n tends to infinity pi of Gn. That is pi of limit Gn equal to limit pi of Gn. We have from above Bmn is contained in Dm, which is contained in Gm. Since pi is monotone, we have pi of Bmn less than or equal to pi of Dm, which is less than or equal to pi of Gm. Now letting m tends to infinity, we get limit m tends to infinity pi of Bmn less than or equal to limit m tends to infinity pi of Dm less than or equal to limit m tends to infinity pi of Gm. Since limit Bmn is Gn and limit Dm is G, we have pi of Gn less than or equal to pi of G, which is less than or equal to limit m tends to infinity pi of Gm. And this is true for all n. Thus letting n tends to infinity, which gives limit n tends to infinity pi of Gn, which is less than or equal to pi of G, which is less than or equal to limit m tends to infinity pi of Gm. That is pi of G equal to limit n tends to infinity pi of Gn. That is pi of Gn increases to pi of G, or limit n tends to infinity pi of Gn equal to pi of limit n tends to infinity Gn.